A Clapeyron three moment method we know. Okay, here we need to find moment about three joints. Here we need to consider two spans. Every span has two endpoints or two supports or two joints. We know the procedure for fixed support. We need to consider infinite span in the opposite direction of fixed support. And we can assume moment about new support is 0. With these assumptions, we need to deal with fixed support or fixed beam. In 13th question, we can see simply supported cases over every span. This is the problem. Please note this question. Determine the bending moment and the shear force plus moment for the beam shown in figure. You can ignore moment distribution method. We are trying Clapeyron three moment approach. Okay, we can consider span AB, span CD, where we can see external loading UDL and point load respectively. Span AB contains UDL. UDL value is 1000 Newton per meter. Can you tell me maximum bending moment? What is the equation? Maximum bending moment equation. Maximum bending moment equation.
QL square by 8.
Yes. WL square by 8. 1000 into 4 square by 8. What is your answer? Your bending
2000.
moment. 2000 Newton meter. Very good. Okay, we can expect 2000 Newton meter maximum bending load at midpoint of span AB. Okay, next we can consider span CD. Here we can see 4000 point load at a distance of 1 meter from right support, that is D. Total span of CD is 4 meter. We can consider only 4 meter length. Okay, what is the bending moment? Bending moment equation. Bending moment. Everybody is talking.
EAB by L.
WAB. WAB by L. What is small a? Small a. Who is talking beside you? Better you are, otherwise you show your video. I will see who is talking. A small a value is 3 meter. Small b value is capital L is 4 meter. A small b value. A small
3.
b. Small a is 3 meter. Small b 1 meter.
1.
Okay, A means length from left support C. Small b means length from distance between load and right support D. So WAB by L answer. Maximum bending moment value over span CD. Very simple question. What about girls? Vishnu Priya, your answer. Maximum bending moment over span AB is 2000.
3000.
Maximum bending moment over span CD value
3000 newtons.
3000 Newton meter. 3000 Newton meter. Okay, in the first case, we need to use parabolic curve because UDL is there. In order to convert UDL into force, we need to multiply UDL value by distance. Again, distance need to be multiplied with the product to get bending moment. So 2 times the distance means x square. So parabolic curve. We can use parabolic curve to show the bending moment value between support A and B. Okay. Next, we can see only point load. So load into distance will give us bending moment. We can use straight line to show the bending moment value over span CD. The value is 3000 Newton meter. Okay, what is the next? We solved 1/4 of the problem. We directly used the equation. We predicted maximum bending moment value for UDL and point load, not at the midpoint case. What is the next step? What is the next step?
3 moment formula.
3 moment formula, which span we can consider. We need to consider
This-
two. And tell me. Okay, here we can see 4 supports A, B, C, and D. Okay, which is to be considered? B, C, D, or A, B, D, or A, B, C. Okay, what is the moment at A and D? Okay, we can solve it easily, but we can have some basic knowledge in order to solve it in simple way. For every simply supported case, we can expect zero bending moment. So definitely support A and D will have zero bending moment value. But we can't expect a zero bending moment at support B and C even though it is simply supported because here we can experience load from previous point. Support B may experience load from support A. Similarly, support C can experience load from support D. We studied Poisson's effect. If you apply load in x direction, we can feel the deformation in other two direction, y and z. This is Poisson effect. This is applicable to any structure, beam structure, truss structure, frame structure, anything. Okay, which is to be considered? Geo, are you here, Geo? Geo, Geo, Jerit, are you here? Tell me your answer. You can unmute and tell me which is to be considered first. Here we can see 4 supports A, B, C, and D, which is to be considered. I told here we need to find only bending moment at support B and C. We can directly tell bending moment value is 0 at support A as well as at support D. Which is span to be considered? You can consider any span, BCD first or ABC first. This won't affect your result. Yesterday, some of you told they confused by taking BC, C not. You can take any span. This won't affect your answer. You can take ABC or BCD first. You can consider span ABC. You can apply 3 moment equation. Geo, are you here, Geo? You posted yesterday. After that, no answer from your side. Are you listening? Are you listening or sleeping? Jarit,
Yes, ma'am.
answer. Tell me the equation. What about your friend? No response from his side. Sleeping.
Ma'am is
Ma'am,
answering in the chat box.
first we have to use span ABC, then BCD, ma'am.
Okay, span ABC formula. Three moment equation. MA
MALAB
plus
2MB
2MB
LAB plus LBC
LAB plus LBC plus
MC LAC is
LAC.
equal
MC
to LBC, ma'am, not AC.
MC LBC. Better all your roommates
Is
can
equal to
answer me. Everybody is talking better. Everybody can answer from your room.
Ma'am, this is Gio, ma'am. I'm there in the class, but my mic is not working.
Then you can sit in my library. You can.
Ma'am, the network issue, some problem was there, ma'am. That's why. I typed in the chat also.
Okay, right side, Jarit. Right side equation.
Ma'am, minus 6
A.
AAB X dash A, ma'am, by LAB.
Okay, XA. Okay, plus
ABC X dash C divided by LBC.
Okay. Okay, very good. Okay, MA value is 0. We can ignore MA term or first term of the left hand side. Next, we need to consider only second term, third term of left hand side. In the right side, we need to substitute all the values. AB value, XA bar value, ABC, XC bar, LAB, LBC. AB value. You tell me first AB equation. AAB means area of bending moment over span AB. AAB equation. AAB equation. We can see parabolic shape over span AB. AAB equation. AAB equation. Very simple question. Vishnu Priya, are you here?
2 by 3 into L into B, ma'am.
Very good. 2 by 3. 2 by 3.
H into B, ma'am.
Okay. Okay. LB or BH anything. Here L value is 4 meter. H value is 2000. Okay. Can you tell me AAB answer? AAB answer. AAB answer. Substitute B value, H value, or L value, B value in 2 by 3 BH equation. Your answer? Everyone can post your answer there. AAB answer. Taking more time.
5,330.
5,333.33 meter square Newton. Okay, next. Next ABC. Okay, after finding AAB, we can find XA bar. XA bar formula. Here we can see uniform loading from support A to B. Okay, XA bar formula. XA bar formula, very simple.
LAP by 2.
LAB by 2. Okay, whenever you see UDL, we can use this formula. LAB by 2. Based on the support, you can change. from LAB to any value, any name, LBC or LCD. Here we can see uniformly distributed load over span AB. So we can tell LAB by 2. If you see mid-point load also, we can use this formula. Total length divided by 2. Here total length is 4 meter. 4 by 2 is 2 meter. So X A bar value 2 meter. AB value 5333.33 meter square Newton. X A bar value 2 meter. LAB value 4 meter. Okay, next ABC. ABC formula. ABC formula.
I'm zero.
Okay, ABC. Okay, ABC no loading over span BC, so we can ignore ABC value is 0. Correct. We can ignore next term. Okay, please substitute everything. Tell me the equation in terms of two unknowns, MB and MC. Two unknowns, MB, MC. Tell me the equation. Substitute LAB value, LBC value, AAB, XA bar, AB, sorry, AAB, XA bar. Tell me the equation. First equation from span ABC. Okay, very simple problem. Okay, initially we consider individual spans AB and CD. Only we noted external load over these spans. So we directly use the equation to find maximum bending moment. We solved. And we noted shape also. For UDL, we can use parabolic shape. For point load, we can use straight line to show bending moment over span. Next, we used 3-moment equation. We consider span ABC, in which bending moment at A will be 0 because this is simply supported. Span B, sorry, support BC, D also simply supported, but here support B may experience load from support A. Similarly, support C can experience load from support D because of Poisson's effect. So we can't ignore bending moment. Using normal approach, we can tell bending moment at every simply supported end will be 0. But here we need to go one step extra. We need to use 3-moment equation in order to find the bending moment at intermediate joints B and C. Okay, what is the equation? Equation. Please substitute everything. Tell me equation in terms of two unknowns, MB and MC. And Catherine, tell me your equation. Don't do any simplification. You can keep as it is because we are using calculator. So you can save the time as much as possible. And Catherine, tell me the equation. And Darshan, are you here? And Catherine, Darshan, anyone can tell your answer? Okay, based on your responses, okay, I can give you attendance. Okay, you can discuss with other friends from other department. Okay, in CSC department and other department, they are strictly following. The students need to respond. The presence not consider as their attendance.
16 MB plus 4 MC
Okay, 16 MB plus 4 MC is equal to?
minus 15,999.9.
Okay, minus 15,999.99. Okay, okay, Judah. Okay, can you type your equation, Judah, in the chat box? My WAP.
Yes, yes.
Okay, 15,999, or you can take it as 16,000, no problem. 15,999.99 or 16,000. Okay, next second part. Second part, Catherine, Darshan.
Yes, ma'am.
Yeah, second part. Second part. We covered ABC. Next. Next, Catherine. Which is the next span? Here, two unknowns. We need to consider two spans. Each span may have 3 supports. ABC then. Okay, thank you, Judah. 16 MB plus 4 MC is equal to minus 16,000. First equation. Okay, next. Span BCD. Span BCD. Tell me the equation, 3-moment equation. You can change the term according to the span BCD. Okay, first term on the left hand side. Okay, Darshan. Okay, Revin. First term on the left hand side of 3-moment equation for span BCD. Okay, Hindu. First term. First term on the left hand side. MB LBC plus 2MC LBC plus LCD plus MD LCD is equal to minus 6 times ABC XB bar by LBC plus ACD XD bar by LCD. So again we can ignore ABC term. ABC will be 0. We can keep only one term on the right side. ACD XD bar by LCD. You can apply the values of every term on the right side, on the left side also. On the left side we can directly cancel MD. MD value will be 0. MA will be 0. So you can cancel MD term on the left, ACD term on the right. Okay, tell me your new equation. New equation. Madhav Rishi, are you here? Madhav Rishi.
Ma'am,
Equation.
MB LBC plus 2MC LBC plus LCD plus no ma'am equal to minus 6 ACD X bar C divided by LCD.
ACD XD bar. We need to consider from right side, from D. ABC XB bar by LBC plus ACD XD bar by LCD. Okay, we know the logic. XB bar. XB bar means centroid of bending moment diagram from left end. XD bar means centroid of bending moment diagram over span CD from right end. We can't consider same left end everywhere. We need to consider left and right. Over span BC, we need to consider left end. Centroid from left end B. Over span CD, we need to consider centroid of bending moment diagram over span CD from right end D. XD bar formula. XD bar formula. Here 4000 is not acting at the midpoint of span CD. It is at a distance of 1 meter from D. What about XD bar value? XD bar value. Tell me the equation. Shiva Bharati, XD bar answer. Sorry, XD bar formula. XD bar formula.
1 by 3.
1 by 3, please check the PDF.
Yes, ma'am. Like 1 by 3 L plus B.
1 by 2, right?
That's from the longer side, no, ma'am. This is the shorter side.
Page number.
5, ma'am.
See, x1 bar, x2 bar we will consider from left and right respectively. We won't bother about longer or shorter side. So x2 bar will be 1 by 2 of L by, 1 by 2 of L plus B.
But the shape is opposite now, ma'am. Like when we draw the moment diagram now, the shape is looks different now, other than this.
The x1 bar means from left side, right?
Yes, ma'am. But that's a shorter side now, ma'am.
You are telling 1 by 3 L plus B, yeah?
Yes, ma'am.
Okay, we can keep 1 by 2 L plus B. Okay, we check the answer. 1 by 2 L plus B means what is your answer? L plus B value is 5. 5 by 3, 1.67.
$2,500.
1 minute. Okay, 2000. Your answer 2000. Okay, please note. Okay, over span CD. Okay, we can use this equation. ACD will be half BH. Here B value is 4, H value is 3000. So ACD value will be 6000. 6000 Newton meter. X D bar value 1 by 3 L plus 1 by 3 L plus B. Okay, please note this equation. Okay, correct. Okay, Shiva Bharati, you are correct. X D bar value 1 by 3 L plus B. 1 by 3 L plus B. Please note this equation. 1 by 3 L plus B answer. 1 by 3 L plus B answer. X D bar answer. L value is 4, B value is 1. 5 by 3 answer. 5 by 3 answer.
1.6.
Okay, 1.67. 1.67 meter. X D bar value 1.67 meter. X D bar value 1.67 meter. Okay, please note. LCD value 4 meter. Please substitute everything. You can get new equation. MA, LBC value is 4. 2MC times LBC value is 4 plus LCD. LCD value is 4. 4 plus 4, 8. 8 into 16. 16 MC, 4 MB plus 16 MC. That is on the left side. On the right, your value, right side value, minus 6 times ACD X D bar by LCD. ACD value 6000. X D bar value 1.67 by LCD value is 4. Okay, right side value. Right side value. Enoch, right side value, Enoch, are you listening? Enoch, Revin.
Yes, ma'am. I'm right side value 2499.
Okay, into 6. 6 is there. Minus 6.
Final answer.
15030.
Very good. Minus
Minus 15030.
okay, 15003. My answer 003 or okay, minus 15,030. 15,300 Ajuda. My answer minus, okay. $6,000 into X D bar value 1.67. Answer divided by LCD value 4. Answer into 6. 15,030, right? Can you check your equation? 4 MB plus 16 MC is equal to minus 15,030. The second equation. Equation number 2. Okay, then we can cancel 2 equations. Use calculator mode. Equation 1, 2 unknowns. A1 value 16, B1 value 4, C1 value minus 16,000, A2 value 4, B2 value 16, C2 value minus 15,030. MB value, MC, MB value, did you get the answer? MC answer, MB answer.
816 points.
Minus 816.17. MC value
Minus 735.33.
okay, minus 735.33. Very good. Okay, correct. MB value correct. MC value also correct. Only little changes, no problem. Okay, now your diagram, bending moment diagram will be like this. Okay, 0 to 816.17 Newton meter. This is not kilonewton meter, Newton meter. And adjoined, see, we can see minus 735.33. Okay, we can connect these values 0 to 816 and then 735. Again, we need to connect MC value and moment at D 0. Okay, above this MB MC, we can see positive value. Till MB MC, we can see negative bending moment. Okay. Okay, bending moment diagram over. Next step. Next step. Next step.
Reaction.
Reaction. Okay, reaction forces. Here we can consider every span. Span AB, CD. Okay, we can move from right. Span CD can be considered first. Okay, we can fix RD value. From RD, we can note other reactions at every support. Consider span CD. We can expect two reaction forces RC and RD. We can tell RC plus RD is equal to upward reaction forces equal to downward external force 4000. First equation, then we can find the moment about C. So RD into 4 minus 4000 into 3 is equal to 0. Okay, what is your RD value? RD value. RD value. I think this is the okay. One more problem is there. Okay, RD value.
Do 8168.
2816. Correct answer, huh? Okay. Over span CD, we can see reaction forces RD, RC, external force 4000. Our aim is to find reaction forces at every support. So we can proceed from the last span CD, especially from RD. Okay. So moment about support C. This is not B, C. Moment about support C. Moment about support C will be RD into 4 minus RD upward force, so positive sign, minus 4000 into 3 plus we need to add moment at support C. Moment value at support C is minus 733.36. Minus 733.36. Four thousand into 3. Okay, here we can see negative bending moment. This negative bending moment can be considered positive. Okay, we know some basics, clockwise and anti-clockwise moment, sagging, hogging. We know some differences. So negative value may become positive. Similarly, over span AB, we can find bending moment. Bending moment about ARB. Okay, first we can proceed from D. RD value is positive 2816.66. Next we can see minus 4000. So 2816.66 minus 4000 will be minus 1183.33 or 34. Negative value, so downward. We need to move the shear force value in the downward direction. It will be 1183.34 Newton. Okay, this value will remain same till section D, till section C. At section C, we can expect reaction force RC. Reaction force RC value is RC plus RD is equal to 4000. RD value is 2816. So 4000 minus 2816.66. Answer okay, from span AB we got RA value. RA value is 1795.83. Okay, we know how to find RA value. Moment about B will be 0. RA into 4 minus 1000 into 4 force into half distance 2 will be moment, plus negative moment will be positive. So RA value is 1795.83 Newton. RA value, RD value over. Next, RC RB value. Here we consider span BCD together. Moment about B will be RD into 8 minus 4000 into 4 plus 37 plus RC into 4 plus moment acting at support B. So we know already RD value, so we can find the RC value. Okay, we know that RA plus RB plus RC plus RD will be external load 4000 plus 1000 into 4, together 8000. From this we can find the RB value. Okay, please note this method. Okay, sometimes we need to use individual span AB and CD where we can see external force, but we can see support reactions because of the effect from previous support. So after finding RD value, RA value, endpoints of the total span, we need to use span BCD, where we can see two unknown reaction forces RB and RC. Negative moment can be positive in your approach. So we know all these values. RC value 1162.5 Newton. So we can move it in the upward direction. Okay, next we can return the same value till section B. At section B we can see reaction forces 2225 Newton. Okay, I try to solve in the paper. I try to post in Google Classroom today. So you try to understand the procedure. That is more than enough. We know how to find reaction force at every support. We need to include reaction forces from previous conditions. So minus 1183 plus reaction force RC will be your final force at support C, that is 20.84 Newton. Similarly, at support C, 20.84 Newton minus 20.84 plus RB. Value will be plus 2204.16 Newton. Okay, we know shear force sign changes for simply supported case. So shear force at support A will be (2204.16) minus 1000 into 4. Value is minus 1795.83. We know RA value, that is positive, so we can move it in the upward direction to close this shear force diagram. Now it reaches 0. Okay, we can close this shear force diagram. Okay, please listen. Very simple approach only. We can consider span AB and CD. Here we can see two more reaction forces RB and RC. It is clueless, so we can start from known approach, that is span AB contains UDL, span CD contains point load. BC may experience forces from previous support, so we can consider reaction forces RD and RB rather than RB and RC. If you consider span CD, we can find reaction force at support D, so we can find moment about C. Sigma MC is equal to 0. RD into 4 minus 4000 into 3. Then moment at support C. Here we can say negative moment that can be considered as positive value. Next, overspan AB. Overspan AB. Here we can consider moment about B will be 0. RA into 4 minus 1000 into 4 into 4 by 2 plus MB value. Okay, we can get RA value, RD value. Next we can consider BCD together. two unknown forces RB, RC. RD is known force. Plus we know that RA plus RB plus RC plus RD is equal to external force. So we can find other unknowns. Okay, try to solve this method. Okay, next problem. Bending moment, shear force diagram, and a moment at every support. Here also we can see simply supported at every support. A, B, C, D, all are simply supported. So we can tell bending moment about A will be 0, about D will be 0. We can't say 0 in between. Okay, here we can see uniformly distributed load over span ABC. So we can consider span ABC, then span BCD. Span ABC and span BCD, we can apply three moment equation. MA LAB plus 2MB LAB plus LBC plus MC LBC is equal to minus 6 AAB XA bar by LAB plus ABC XC bar by LBC. First equation. Okay, next we can consider span BCD. Here we can fix MB value also. MB value will be WL square by 8. We can fix MB value also. So we know two values, MA value, MB value. So we can consider span BCD alone. Span BCD alone. Very simple. Very simple. It may look very tough, but very simple. Here we can see uniformly distributed load till section C. So we can directly fix MB value. MA value will be 0. MD value will be 0. We can consider only span BCD. Three moment equation for span BCD. We can solve it very easily. Okay. So try to consider span BCD alone. Okay, try to find MC value. Reaction forces normal approach. We can start from span CD. We can find first RD value. Then we can move in the reverse direction, right to left. Okay, today I will post the material. Okay, please practice. Okay.